Welcome friends to one more session on the fault analysis or DR analysis using SIGRA software. In the last two sessions, we have discussed about the DR analysis of a Siemens 7SA522 distance relay using SIGRA software, and we have also discussed about the fault location calculation using SIGRA software for 7SA522 relay, or for that matter any other relay. You can determine the fault location using SIGRA software. In this session we are going to discuss about the DR of one of the Micom P444 relay, and in this session we are going to discuss the how these analog and digital channels are configured in this P444 relay, how with the help of analog and digital channels you can determine whether the fault is in A phase, B phase or C phase, and what are the informations that you can gather from this analog and digital channels. Also, we are going to discuss how to combine two fault records in a single file, how you can view the circle diagram of P444 relay. Everything we will cover in this session. It will be a short, interesting session, I hope. And the DR that I am using is exactly the same DR that we have considered for 7SA522 relay, and this is also the same type of fault, the exactly same fault I would say for P444 relay. So now, without wasting further time, let us start with today's topic. As you can see here, I have already opened the DR which is available in my this folder, and this is Micom P444 DR which I have opened, and now presently this is selected as RMS value. So first we have to select it as instantaneous value, and now you can see that the important thing over here is in this description box. Here the sampling rate is shown as 1198 Hz as compared to 1000 Hz in Siemens relay, and this 1198 Hz means for a 50 Hz system this is 24 samples per cycle as compared to 20 sample per cycle in Siemens relay. So more is the number of samples per cycle, better will be the accuracy first thing, and the faster will be the relay performance. So now I am not going to discuss in details about the analog and digital channels because we have already discussed these things in Siemens DR analysis session. So first of all, let us see here that in this case you have four analog current channels IA, IB, IC, IN, and four analog voltage channel VA, VB, VC, VN, and these all are shown in kilo ampere and kilovolt. That means this DR is in terms of primary magnitude. And now if you see here, in case of pre-fault, the current magnitude of R phase, Y phase and P phase, or A phase, B phase and C phase are comparable. However, at this particular point of time, there is a spike in R phase current and neutral current, which shows that this is an R phase to ground fault. And also you can see from here that there is a dip in R phase voltage. So these two conditions, that is the increase in R phase current as well as the decrease or dip in R phase voltage, suggest that this is R phase fault. Further, since there is a current in neutral, so this is R phase to ground fault. Now if you see here, the first event which the first digital channel which gets activated over here is any start, and this is in case of Micom relay internal DR channels, internal digital channels. In case of Siemens relay, you would get the first signal. If you can remember from the last session, the first signal was 21 pickup or distance pickup. In Micom relay, this is designated as any start, or if you have configured here a distance pickup or distance start, then you might have get this distance start as well. But since we have not configured that in this DR, in this particular DR, so we are getting only any start. So now after some one or two samples or within one cycle, now relay has taken the decision that this fault has settled into zone 2. So zone 2 and zone 3 both picks up now. And this is exactly the same case of Siemens relay also. In that relay, first of all, distance protection picks up, and after that, zone 2 and zone 3 both picked up simultaneously. Now, once zone 2 and zone 3 picked up, it will trip only after the elapse of zone 2 or zone 3 timer. But before the elapse of that timer, there is a signal which is getting high over here. This is distance signal receive or distance channel receive. This means that you have received a carrier signal from remote end, which suggests that the fault is in the principal line itself. Zone 2 is in the pickup condition and carrier signal is received from remote end. So relay must issue a trip command instantaneously on receipt of this carrier. So now if you see by using this cursor here, the relay has issued a trip command. Now this is any trip command, so it does, from this signal you cannot decide that whether it is a distance trip or SOTF trip or DEF trip or over voltage trip. But one thing is sure, that relay has issued a trip command. But now if you see the second signal, which suggests that this is a distance trip, and this distance trip is for A phase. And why it is for A phase? Because the fault was in A phase. So relay has issued a distance trip A. Immediately after the issuance of distance trip A command, your breaker should open, and this is what happens over here. Your R phase or A phase circuit breaker opens, and after the elapse of that time, which is this time, which is close to 1 second, your circuit breaker closes, and once your circuit breaker closes, the current and voltage must start flowing. So once your circuit breaker closes, you can see from here that current and voltage both, this is the current, and now the voltage is also available here. And in the last session already I have explained that why this voltage is available before the closing of circuit breaker. This is because the dead time of remote end is lower as compared to dead time of R end. So now by using these signals, you can easily analyze a particular tripping. You can easily analyze any tripping if your DR is configured properly. Now the another thing which I have explained in the last session also, which is your circle diagram. So now if you see here, in this circle diagram, presently you are seeing over here is this zone boundary, and these zone boundaries are not for this P444 relay. This is basically for Siemens relay, because just wait 1 minute. In this folder, if you see here, you don't have any RIO file related with Micom P444 relay. In this folder, I have only the CFG, that is ComTrade file, and DAT, that is the data file of P444 relay DR. The RIO file which is available is for Ciprotec DR, and since I have just used this DR for the analysis or for the video session of Hindi session, then I have already saved the DR or that RIO file. That's why I am seeing over here this DR or this distance protection zones characteristic, but this characteristic is not applicable for your Micom relay. Now the second thing, if you see here, you are not getting any characteristic, or you are not getting the zone or the characteristic curve entering the zone. The reason behind this is we have not configured this network properly. So first of all, go to network and then select IA, IB, IC, and enter this at primary value. Similarly, select VA, VB, VC, and VN, and then select OK. And now you can see that your this characteristic curve of R phase to ground, Y phase to ground, B phase to ground is available here. One thing which I have missed is in the network configuration, just enter this, the CT ratio and also the PT ratio. Once you enter these values, your characteristic will come here. But since this zone reach boundaries are for Siemens relay, so you cannot easily estimate, you cannot easily determine the fault inception as well as the point where the characteristic enters inside your zone boundaries. For that matter, what you have to do is you have to import the Rio file from your P444 relay to this folder, or directly create a Rio file using Rio file creator or using Omicron kit, and then use that Rio file for better characteristic or for the characteristic that matches with your relay settings inside the P444 relay. Because in case of Siemens relay, if you enter, and if you can remember the Siemens relay setting, the phase to ground loop, the total resistance, the resistive reach and reactive reach is basically the resistance multiplied by the factor 1 plus Re by Rl, and similarly for reactance 1 plus Xc by XL. And this Xc by XL and Re by Rl is for your ground fault compensation factor, which is uh, R0 minus R1 divided by 3 R1 for resistance, and similarly you can determine for reactance also. But in Micom relay, you doesn't have to enter those factors in case of your zone reach boundaries, and there you enter only the impedance and the resistance of your zone 1, zone 2, zone 3 and zone 4. So that's why these characteristics of Siemens relay doesn't match with the characteristics of your Micom relay. The only factor is that you will get the same type of characteristic for both relay, but the magnitude of resistive reach and reactive reach will be different for Micom and for 7SA522. So now the next topic that I want to discuss in this session is how to enter two fault records in a same DR. So you have to go to this edit and then go to fault record and then go to add, and now select the second DR and open. Basically, this second DR in the same file, it is used generally for double-ended double-ended DR analysis. In case you have the DR available of remote end as well as local end, and you want to analyze DR for better analysis, then you can use this method. So if you see here, now I have added first DR, which is the Micom P444 DR. If you see here, this is Micom P444 DR with sample rate 1198 Hz, and second DR is for your Ciprotech DR with sample rate 1000 Hz, and this is your R phase to ground fault, which is the same in case of Siemens relay. Also, if you see here, this is the R phase to ground fault. Also, if you see here, the first signal which is activated in case of Micom relay is your NE start, and the first signal which is activated in case of Siemens relay is your distance pickup or 21 pickup, if you see here. So both relay are working exactly on the same line. The only difference is the timing difference of the operation between two relays, and that is probably due to the difference between these sample rates. For Siemens relay, it is 20 samples per cycle as compared with 24 samples per cycle for Micom relay, and that's why there are some time mismatches between these two relay DR. But the operation wise, for the protection wise, both relay operates in the same manner. Both relay first picks up for non-directional distance, and then the fault enters into the zone 2 or zone 3, and after the receipt of carrier, if zone 2 is already in the pickup condition, then relay will issue a trip command immediately, and once the relay issues trip command, then your breaker will open and fault will be isolated. After the elapse of that time of 1 second, your breaker will be closed and line is now again delivering the power which it was delivering before the inception of fault. Also, this type of twin DR in a single file is helpful for DR analysis in case of the DR, if you have the DR of remote end and local end. And the one important thing that you can do in that case is you can synchronize the fault records also. So suppose if the fault record of one end, that is the fault record of suppose local end, is triggered at some different time, and at remote end it's triggered at some different time due to non-synchronization of IDs at both end, then you can synchronize those both DR by manually by using this option synchronize fault records, and then shift this fault record of any end as per your convenience, as per the difference between those two relays time, recorded time. So now I hope the concept which is explained in this session is clear to you. In this session, we have seen how to analyze the Micom P444 relay DR. In the next session, we will discuss about the analysis of REL670DR, and then we will move to Wavewin software. In the Wavewin software also, we will discuss the same concept, the analysis of DR of 7SA522 relay followed by P444 and REL670. I hope the concept which is explained in this session is clear to you, and if you like the content, then please share this video with your friends so that more and more people gets aware about these concepts, and more people will learn these concepts and they can apply in their organizations. Also, if you didn't like the content, then you can comment in the comment section so that we can improve upon based upon the feedback received from your side. Thank you again. We will meet with some new topic in our next session. Till then, goodbye.